All right, got a 2013 Ford Fusion. This is a new one for me. I haven't had to deal with this particular code. The car came because it was in limp home mode. It didn't want to go with 5 mile an hour, 5 mile per hour from what the customer stated. So I took my generic or my spare tool here and retrieved some information before I got the other scan tool, the MK908. MK908 is the other tool we'll be using. My spare tool is the MP808. People inquire about that a lot. So here's a screenshot of the codes that were present. Now, the cylinder head over temperature protection active, I'm pretty sure that's what caused it to go into a limp home mode. But the one that I'm going to address first is the low pressure fuel system pressure. It's a sensor, but that states that it's too high. So not the voltage, but likely the pressure is too high. And once I started looking at PID data, I looked at some freeze frame data. I was like, you know what, we're just going to go with this first one first. And whatever comes back, we'll just make another video and address that later. But we have P008B. Once I looked at the definition of this code on my Identifix, it didn't specify anything specific. It didn't have any code setting criteria as far as description go, because it went with a another code. I won't be able to tell you at the moment, but the code that would be affiliated with this P008B isn't affiliated with what they were referring to in two Identifix on some of the case studies. So I'm going to address this one first. Whatever happens after, we'll address later. Let's see here. Evaporating emissions, purge, flow, performance. That probably may be something related to the purge valve. I know some of the other Focuses had issues with their evap purge valve. It may be sticking or something. I'll address that in the future. That's not going to cause a limp home mode, but the overheating protection wheel and this low fuel pressure system pressure too high. I think that will too. Now I want to show you what I found out when I checked this P008B, and this was pretty much stuck out like a sore thumb when I was looking at the PID data here. So we got the 2013 Fusion. We're going to go to some live data, and I'm going to show you what that looks like. Here we go. So we're going to go to, there's no codes present because I did clear those. Diagnosis. We're going to go to control unit. We're going to go right into the PCM. Live data. I'm pretty sure I probably would have had to have driven the car to get that P008B to manifest again. I just pretty much, it was back then when they towed it in here, and I just flipped it around, so I highly doubt it. But as intelligent as this car is, I'm pretty sure it should have picked right up on it. For this car, for the engine to be a 1.6, the turbo definitely spools pretty quick, though. I give it that. I don't know how it responds power-wise. The scan tool is a little slower. All right, so we're going to go down to, so we're going to have fuel rail pressure, and then we're going to have fuel low pressure. Let's go here. So we're fuel rail pressure voltage, fuel rail pressure desired. That's kPa. I'm going to convert that over to PSI. No. Oh. See, I am really not that observant, man. So it's already on PSI. Let's go down to fuel. Low pressure. I think it was low pressure fuel. Okay, low pressure fuel. So that's what's in question, because that's the actual value. This is what's desired. It stayed at 109 while it was running, and that's what I'm like, okay, something's up with this here. Look at the voltage. So we're gonna pull these PIDs here. One thing, there was two options I thought about. I could either wait for this fuel rail pressure to bleed off, because there's a couple things I'm thinking that could have been the culprit here. If the high pressure fuel pump, let's go here, if the high pressure fuel pump in the back over here is bleeding off, let's just say hypothetically, if it's bleeding off and it's backflowing into the low pressure fuel side, maybe it's just bleeding off to the point where just having a near max value. Maybe there could be something wrong with the fuel pressure regulator in the fuel pump assembly, assuming that it does have a fuel pump assembly. I don't know, but I'm pretty sure it has a fuel pump assembly on this vehicle. The fuel pressure, low pressure sensor, it's going to be right there in the back. That's where it's going to reside. So I'm thinking the high pressure bleeding off, getting back fed into the low pressure side, but it logically wouldn't, because it would equalize and it would just blow some stuff up, I'd imagine. That's one. Two, defective sensor. Three, we have a faulty fuel pump assembly. I'm going to go with, I think the sensor's probably defective, and I'm going to test that first. So I was thinking, if I let this bleed off low enough, it gets below 109. If this bleeds down, then we could have a problem with our high pressure fuel pump. Could be. I'm going to encourage this to bleed down more rapidly by just pretty much breaking the fuel line. This really not recommended because of the high pressure system, but I'm in a rush here. So I'm going to crack the line, let it bleed off. Then once it goes below 109, what is this value going to do? If the value drops, I probably could suspect a defective high pressure fuel pump. If it doesn't drop, I'm still going to suspect either the pressure sensor is defective or the fuel pump assembly is defective. And we're going to narrow those last two from the fuel pressure sensor to the fuel pump assembly by testing the pressure sensor. So let me crack this line here. So it's gonna be a 17. Here's our high pressure fuel pump. Now, again, I'm gonna crack this line. This looks like it goes directly. All right, change of plans. What I'm gonna do, since this line here is the feed line, I thought it was going to the high pressure fuel pump, the high pressure fuel rail, but that's over here, and it's pretty much hard to get to. So I'm gonna have to crack this line, and if I'm gonna monitor the high pressure fuel side and see if that has a high drop off, and we're gonna monitor the fuel rail pressure, low pressure side, see what that looks like if it drops. And then we're still going to test it. So it's just unfortunate I'm not going to have certain questions answered. But let me get this camera set up here. I'll just say when I'm cracking, this is what we're going to watch: fuel rail pressure and low side. So those two there are highlighted. All right, cracking the line now. So the low pressure should be dropping. If it doesn't drop and it stays static, then we just have a bad sensor. Look at that. There shouldn't be any pressure in there. So this answers my question. What I'm gonna do, I got a few ways I can also test this, since I know for a fact I don't have any fuel pressure in here. I took the line off. It's nothing in there. Oh shit. Sometimes it'll shoot back out at you if you have it off and it gets heat soaked and pressure build up. Let me put this back. So there shouldn't be any fuel pressure in there. Hopefully I got that in there. It didn't. I don't like the way that felt. I didn't like the way it felt, but I think we should be fine. just didn't feel like it was straight. So one other thing that should have dropped the fuel pressure on the low side, what I'm gonna do, I'm gonna disconnect the actual sensor right here. If you see my hand is right by the scan tool, I'm gonna disconnect this sensor and see if it falls off. Okay, so it went high, which is normal. The value should go high, simply because it's completely disconnected, and it probably uses a resistance. So the higher the value, the more resistance, the lower the value. I think I said that right. So if it's disconnected, it's high resistance. Once the pressure builds, it lowers the resistance. It lowers the resistance, which in turn lowers the voltage value. So that's how that works. So I'm gonna connect it and it drops. So what I'm gonna do, I'm gonna hit on this damn thing and see what happens. Nothing changes. It should have dropped to 0. What I'm gonna do, gosh, what else could I do? Use a test light and make sure. Well, I could check the voltage values. What if I skip testing the voltage value? Because if I've had that happen in the past where I skipped testing stuff and shot myself in the foot. The voltage is high, so if I just put a resistor to it to drop the value like a test light, shouldn't I technically be able to see the value drop and the pressure drop on a low fuel rail pressure side? So let's find out where our sensing wire is, which should be a bias 5 volts. And I guess we could put the test light to it. Let me. You're gonna have to forgive me because I honestly did not read any diagrams or anything. This is just a regular test light. Here's our value, low side value here. We'll just keep looking at these values while I pierce. I need a ground. I need a ground side. I'm going to shock. There's one right here. I'm gonna go right there. There's a good ground. And let's see what happened with our values. I'm just taking a stab at this, no pun intended. No. There's our voltage side right here because the test light is dimly lit. Sensing probably should be in the middle. Yep, okay. There's our sensing on the end here. So lightly, this is going to be our ground. Let me put it on 12 volts. This should illuminate. Okay, so 5 volts, ground, signal. It dropped in value, which should be an indication that we can drop the value. The pressure has the capability of dropping low. So the sensor is defective. I'm gonna be pretty. I'm gonna give myself. I'm not gonna back myself up on anything because we pulled the pressure. The sensor didn't change the value. That stayed the same. The low pressure side stayed the same. We disconnected the sensor. It did go up, so it does have the ability to change to a degree from the value that it was at. When I put the test light or resistor to it, it dropped the value. So, like I was stating. All right, just got back from my store, O'Reilly's. Let me see if I can get zoom in right here. So I got the sensor. We had this in stock. The part number, because a lot of people are like, give me the part number, is FPS49. There you go, for those who care about it. Because I don't. It's just a sensor. So what I'm going to do, one thing I noticed once I cut the key off and cut it back on and went to like a default position, I wonder if that's because I dropped the value, and then that's probably default. So I'm gonna plug this up. I haven't done it yet, and I don't know what this literature is. I don't think I. And we're gonna see what happens. It should go to 0 because it's at atmospheric pressure. I would imagine. I thought it'd probably be like a. Oh no. No. Why did he give me? He gave me the wrong one. Dang it. Oh gosh. You know what? This is likely my fault. And I went on Rock Auto, got a part number, and this was my fault. It's not your fault, Ken. All right, I'll be right back. It's a new day. I had to call O'Reilly's and order the appropriate fuel pressure sensor. This is the proper one here, p008B. So there's 2 pressure sensors. You got a high pressure and a low pressure. The fuel rail pressure sensor is going to be here, and they look different. Let me show you. Oh, if I can pull this joke off, pulling off the wings there. It's the back. Okay. So if you look at the fuel rail pressure sensor, it has these tabs here. The new one is going to be smooth. It's not going to have that. Well, we already got the code. I'm going to show you. We got the code here. Before I show you that one, this is the only code that came back. I've driven the car 40 miles. P008B, which is the low pressure fuel system pressure. So that's the code. We already got that. So we already got that established. This is the difference with the other sensor. This smooth on top. Now I simply could have just pulled the new one out, but I haven't opened the box up yet. All right, so we know from yesterday that the static, like a base, well, not static, but the fuel pressure was reading 109 psi. So what I'm going to do is we're just going to plug this one in and see if it goes to 0. And I was doing some thinking about the value change when the car is on, and me, testing the fuel pressure or just making some changes. It should have dropped. The fuel rail pressure sensor did drop. So logically, when the car's off, key on, engine's off, key on, that low pressure fuel pressure sensor should also alter, so it doesn't have to be on to be functioning. We're going to go to live data, and we're just simply going to plug this in. And I want to also add, I had the low coolant issue, and I'm pretty sure that's what contributed to the fail safe and going to limp home mode. What I did, I'm going to show you that also. Let me go to the live data. What I noticed, and I'm going to update this information on Identifix also because there wasn't any information. There's nothing wrong with the coolant pipe. That's what meters the height. From what I understand, this should meter the height of the coolant. Now, the values that I was getting when the fault was occurring, and this was pretty immediate, when I would start the car up and drive, when I would start the car up, it would be at 80 millimeters, mm. I think that's the unit of measurement that they utilize. And then it would drop to 79, 78 when I start driving the car. The light would, not the light, but the check, there will be a code that would immediately come up. So once I topped the coolant level off, it went to 100 millimeters, and that shut the light off, and I haven't seen it since. And this is the only code that's coming back. The evap code hasn't even came back yet. So let me find the appropriate, let's see, there's coolant level. So we have our low side pressure here, which is different now. It was at 109, now it's 115. Engine coolant level, there it go right here. Engine coolant level, okay. I just want to show you that. So this is at 106 millimeters, and that's normal. I would consider that normal because the light hasn't came back on, and again, it would immediately come back on once it dropped below like 80. Or it was around 80 to 79. So if you have any issues with that other code, I'm gonna put it at the bottom. This is how I fixed that issue. There had like been other issues where there could be jumper harness or communication problems, but we're not addressing that. I don't want to get too far off. So I got the sensor disconnected. I'm gonna plug this in there because it should be at a 0 value. And we're gonna simply plug this in here and see what it says if it changes. All right, I'm gonna before I like connect this new sensor, I'm just gonna get the voltage value, because one thing I didn't do was test the voltage value, so I don't know specifically what's supposed to be what. Let's pull this out here. So we're gonna see what the voltage value is supposed to be on this circuit. I don't know if it's a 5 volt, 12 volt, I don't know. And I know one of them was biased. I know one of them on the end was a signal. I don't know. So we got it on voltage, direct current. And I'm going to look for the ground first. So I'm going to put my lead here. Test it first. So we're looking for ground voltage first. So I'm going to this blue wire, which is, this might be signal, the blue one. Okay. That might be 12 volts. Okay, so the middle one is ground. That's the tan and purple looking wire. So the middle one's ground. We're gonna look for 12 volts or the voltage source. And I remember one of these on the end. Okay, so I think, yeah, that's 5 volts. I'm not sure if that's this is 5 volts. So these are both 5 volts on the end here. So that's just testing for voltage value. Let me use my test light to test the load. The actual voltage value of 5 volts would produce actual amperage, like current. So I'm gonna let me use a test light. So I'm gonna get grounded here. So when I apply the test light, the light should illuminate if it's actual usable voltage. So this one's lighting, this one isn't lighting, and it changed the signal on the computer. So the blue is going to be the signal, tan and this brown here, or purple, this one in the middle, is going to be ground, and then the brown and black, what looks like, is going to be our voltage, our 5 volt source here. Let me see if I can zoom in on that so we can see it a lot better. All right, so looking at the wire connector, we have our voltage, our 5 volts. Our light illuminates. So the brown and black is going to be voltage. This center wire, the tan and brown, I want to say, is going to be our ground. And this blue and black here on the end is going to be our signal wire. So we got signal, ground, voltage. That's how that goes. Let's look at the computer and see, once we connect this sensor, does the voltage value go down? And we can confirm that we were right in diagnosing this, and I would call it like a legit diagnosis, obviously. All right, here we go. Which one we're looking at? This is the one we're looking at, low pressure. So if everything's right, this should drop with our new sensor. Voila, cool. So what I'm gonna do, we're gonna change the sensor out. and this will be fixed. Now our low pressure, the actual pressure, should meet the desired pressure once we get this replaced. We're gonna try to remove this for space. You don't have to, but I don't think anybody can see there. We'll see what that works out. So I got a 13, well, a half inch. I feel like a half inch on the bottom here. There's a base where you can get a hex. Feels like, yeah, I think it's not a hex really, but you can get something in there to keep that base steady. I'm gonna use an adjustable wrench. This will fit. I didn't bleed the fuel system. You would definitely want to do that. Let me see if this will. Need some leverage. I feel like a 13. Be very careful. Oh gosh, that's on there. Man, that's on there. Yeah. I wonder if I need a way to get some more leverage. I took the air box off to get some more room. I just used a flathead, and there was some quick connects. You just push those tabs in and pull out. Very easy. Oh gosh, let's see if this works. Oh man, that is on there. Is this reverse thread or something? I don't know if it's reverse thread or not. Not sure. Pretty sure it's not reverse thread. No, it's standard, it's regular. Could the fuel pressure be causing this? Maybe the fuel pressure is competing up against it. I'm just going to relieve that. Try this again. Oh, it's got bad angles. I don't want to try. Okay, here we go. Just bad angles. And probably a combination of the fuel pressure too. I don't know what anybody saw, so I'm just gonna screw this off. Some residual fuel pressure. This is like useless. You wanna put the new one on. And I'll be honest, I do not have torque specs. I'm going to snug this down. Uh-oh. Snug it down to where I feel comfortable. You would have to find the torque specs for this to be 100%. I don't have that. Be straight up. So do this at your own risk. All right, let's put this. I lost my flathead. I couldn't even find a damn thing. All right, let's look at the PID data and see what that looks like. Zoom in. For those who always inquire what scan tool. That last one I had to do a flood clear. I guess it had like a fuel dump, but it's running fine now, and it looks like we have some attempt at stabilizing the fuel pressure. Now, I don't know how it's supposed to react. Normally when cars have a desired versus actual, it's a lot more stable than this. I don't know why I did that. Maybe it's just how it populates. It's a little too rapid, and it's not like a 1 second time base, and it's probably something a little bit more less, I guess. Let me see what the signals look like on the graph. I mean, it's not. I'd imagine it's not going to be 100% stable because of how the fuel pressure, probably because of the demand of the high pressure fuel pump. But I mean, it's not stuck. And I guess once I drive the car, we'll see how satisfied it is. Let's go to the race codes. No, it's not shut down. I should have, you know what I didn't do, and see if the EVAP system was satisfied. I'm not going to worry. I'm still going to drive about 40 miles or so and then recheck. But I'll definitely update the comment section, not the comment section, but the description of the video if anything changes. But I'm very happy and satisfied with how everything is pan out. Simply because it was obvious. Like once I did a test, we could manually alter the pressures based off the signal, and put a sensor to it. It dropped to normal atmospheric pressure, 15 psi, about 14. So that's normal atmospheric pressure. It's not going to be at zero. So I'm pretty confident that the car is going to be satisfied, and the check-in light's not going to come on. Again, that issue with the coolant level, in my case, I just topped the coolant level off. And anything, if you look at the PID data, if it was below 70, fuel rail. Oh, you know what I did? This is why. Damn it, that's probably why I didn't start up immediately, because I don't know the fuel pressure. I forgot to hook this back up. Yeah, so that'll do it. Let me clear this code again. That was stupid on my part. Okay. So despite that high pressure fuel line not being connected, it still fluctuates real rapid. So I guess it's just how rapid the computer is able to process the information, and it just fluctuates so greatly. But I guess as long as it's around it and it's not stuck, maybe it's the sensor quality. I'm not sure. But like I said, I'm going to drive the car and see if it's satisfied with it, and that'll pretty much determine as far as any further direction. Let me cut this car down. So that'll that high pressure sensor not being connected will explain why I didn't want to start up, because I'm pretty sure that controls the pulse width modulated abilities of the high pressure pump. So I know people like you talk too much, and yeah, I talk too much. So I like to give a lot of information, but I'm gonna go back. Now again, I don't know if you heard me, but that code was set because of the low coolant. Top the coolant off. That's fine. The code didn't come back. We know now if that's the high pressure fuel, the fuel rail pressure sensor, if that's not connected or some issues with that, you're going to have some startup and drivability problems. So we learned something new today. We learned how to test that joker. I didn't see any description on how to test this sensor. Most of the people on Identifix pretty much replaced it. I wish now we know what we can go about diagnosing and testing it. Some things you can't use a test light to test the signal system, but in this case, it wasn't sensitive. We were able to use the test light to test the abilities of dropping the signal, and it worked perfectly fine. We saw that reflect in the computer system, so that worked out. So we know the voltage going to the sensor is 5 volt. We have a ground, and we have a 5 volt, like a reference for the signal side. That's going, we also know that is like a bias voltage that it utilizes as a reference there. So so we actually have 5 volts, 5 volt reference, and a ground. Other than that, this car seems like it's fixed. Like I said, if anything happened, I'm going to update the description, and if there's like any notes I need to add, I'll definitely put it in there just in case somebody like have to go through this issue. But I think this is pretty much concrete as far as testing and replacing without having to throw a part at it. But if anything happened, I'll update. But other than that, hit that link, subscribe to the channel, stay informed, have that reassurance of my work. See you on the next one.